Dr. Manivannan, Professor, Department of Applied Mechanics, IIT Madras, coordinator of this FDP event, Dr. Glenn, and my faculty colleagues, respected participants from all across India. First of all, I thank you all for joining this event online, and especially Dr. Manivannan for sparing his valuable time to deliver the opening lecture on this event. And all participants, we all being the part of the teaching fraternity, it is imperative that we embark on the journey of lifelong learning. As we tell our students, I think we need to walk our talk, and we do that through this kind of FTP programs. And fortunately, we have got a wonderful topic today, which is quite relevant for the current situation. We all know that because of this pandemic, the process of digitization has become accentuated. Perhaps it has accelerated. It's a good thing that has happened to the technology or the process of digitization. Now that even beyond the pandemic, I'm quite sure that we will get resource persons all across the globe, and that's a real boon since we could collaborate and communicate over net more effectively. But when it comes to, for example, this meeting itself, generally we accomplish any task in our professional and personal life through interacting with our environment through our senses. Primarily out of the 5 senses, perhaps we use our vision, hearing, and touch we rely on these things. Especially perhaps with the touch phones, we know that how frequently we are using or how extensively we are using our thumb and fingers. Perhaps except for that revolutionary thing which has happened perhaps 2.5 million years, wherein we have developed this opposed thumb for the Homo sapiens, with which we could grip things better than other apes, and stone tools, perhaps we manipulated that better with our opposed thumb, and with that we manipulate now the yoke of big aircrafts, and unfortunately now even the yoke is disappearing. For example, in Airbus 370, we don't have a central yoke, we have only a side stick. But when we are operating in such situations, we need good feedback, and we need to get that feedback, otherwise our operations will not be successful. And in this meeting, even though we are on this virtual reality mode, it's not becoming much of a reality, because in a real classroom, we could have turned our head around and seen people in a better manner, and we could have interacted with better. We could hear them, see them better. But here, even after moving the mouse, even after zooming on or pinning on persons, we could see individuals, but the way we could interact with the people may be limited by these operations. But if we could really enhance on this and make it real virtual reality with a headset, and we could see the people, it would have been more wonderful. Perhaps I am sure that the discussions we have today in this FDP will definitely help us to evolve systems, which will help us to have better virtual reality systems for education or medicine, or for operating even in difficult terrains, because we operate a lot of not only military equipment in industrial situations, industries, or in difficult terrains. We have a lot of remote operations with the virtual reality. Right now we are doing it, and its applications are going to be a little higher in the coming years. So I am quite sure this is the right topic, quite relevant for the current scenario, and an emerging topic which has been chosen for this, and I'm quite sure that the experts will enlighten a lot on it. And further enhancing of the virtual reality, right now itself we can see that in this pandemic time, most of these car manufacturers, for marketing purpose, they rely heavily on virtual reality and augmented reality. And in the coming days, we will see more of imposition of layers of information on the real world. That is imposition of digital world over the real world, so that we will get an enhanced vision and augmented vision of things around us. Even though Google Glass was stopped long back, but Apple is coming out, and of course, all the competing companies like even Oppo is coming out with Google Glass like thing. And with the advent of 5G, I am quite sure that in real time data, we will get better data, greater amount of data, and our augmented reality scenes will become more reliable, more instantaneous, and we are moving towards that brave new world. And this technology is quite relevant, and I congratulate all of you for taking up this FTP, and I wish this program all the best. And thank you once again for joining this event. Thank you, one and all. Over to the anchor.
Thank you, sir. It is said that integrity, insight, and inclusiveness are the three essential qualities of leader. With great honor, I welcome Ma Dr. Joseph Pamplani, Auxiliary Bishop Talsheri and Chairman VJEC for inauguration.
Respected Principal, our beloved Professor Dr. Benny Joseph, and our Chief Guest, Dr. M. Manivannan, one of the academic giant from IIT Madras, and all other dignitaries who are joining their hands to make this dream project a reality. And I should also address our beloved Vice Principal and the man of this program, Dr. G. Glan Devadas, and the wonderful speakers of this August program, and our beloved faculty members, and all those who are participating in this great event. I am happy to say that this 5 days ATAL sponsored faculty development program organized by Vimal Jyoti Engineering College, especially by its flagship department, the Department of Electronics and Instrumentation, will be a great landmark in the history of the Vimal Jyoti Engineering College. This college is actually situated in one of the hilly areas of the northern Malabar of Kerala. People would be usually amazing, how did you choose such a locality for building up this great educational institution? Usually the educational institutions are meant for the upper class people, but the Archdiocese of Tellicherry had got a real vision that whenever we launch an educational enterprise, it must be meant for the least and the last, especially the marginalized who are often deprived of higher education facilities. And our dream had been, what we had envisioned as our dream had been materialized by the expertise of the great personalities like Dr. Benny Joseph, our principal, and Dr. Glan Devadas, and our illustrious professors who are working hard at Vimal Jyoti Engineering College. As the chairman of this college, I take this to the management is really proud of you and your achievements, especially what you have done during the innovations that you had made at Vimal Jyoti. Your social commitment to face this reality had been applauded by our Chief Minister himself, as well as from so many other dignitaries of Kerala society. Some of your inventions had invited global attention, and we are really proud of you. And the thanks of the management is beyond words to our beloved professors. And coming to this 5 days ATAL sponsored faculty development program, I had seen you had taken a topic related with robotics, Virtual and Augmented Reality for Robotics. That is the title of this program. And you know that my field is something different from that of robotics. I am an illiterate with regard to the field and that subject. But I am really fascinated and attracted towards what you are speaking about, because even an illiterate with regard to robotics are well aware of the importance of the robotics, how marvelously the robotic science is contributing towards the development of humanity, especially in the manufacturing field. As far as I know, the robotics is the science that had combined both computer science as well as the engineering technology. I remember once I had visited a car making factory, the famous Audi car, Audi in German. It's a factory located in Ingolstadt. It is in the Bayern. And when I visited there, the managers had explained to me, they had 30,600 robots working at their factory. And I had seen almost 6 kilometers distance. All the robots are working unanimously, and the net result is the wonderful Audi car. This is my primary experience with the performance of the robotics. But I know that this robotics is really contributing towards humanity. It is almost replicating many of the activities done by human beings. When it is able to perform certain activities which are beyond the capacities of the human beings. For example, the bomb detection, the bomb deactivation, working in the field of radioactive areas, all these. And this robotics is the science that is contributing towards the enhancements of the powers as well as the functioning of the robots. So even an illiterate person like me is interested in the contributions made by the robots. So thank you, dear professors, that you had selected this wonderful topic as the topic of our 5 days faculty development program. And all the teachers must be real students. The Paulo Freire, one of the Brazilian thinker, I remember his quote. He says, an education is always an unending correspondence or a conversation between a teacher-student and a student teacher. That means a teacher must always be a student. And that is exactly what is envisioned in this faculty enrichment program. And I am sure that you all will be benefiting out of it. Thank you very much. And I sincerely congratulate Dr. G. Blandevadas, the man behind this great event. I appreciate Dr. Benny Joseph, who is organizing everything in a systematic manner. And the excellence of Vimal Jyoti is owing to a great extent to his academic excellence and systematic organization. Thank you, dear professors. Once again, I thank everyone. When I had gone through the list of presentators, I had seen almost are present here. Thank you very much. Thank you. Thank you once again. With these words, I declare these 5 days ATAL sponsored faculty development program on virtual and augmented reality for robotics open. Thank you.
Thank you, Father, for those kind words. Next, we have the eminent personality, Dr. M. Manivannan, Professor of Biomedical Engineering in IIT Madras, Department of Applied Mechanics. He received postdoctoral training at MIT in Cambridge. Before joining IIT Madras in June 2005, he was serving as a chief software architect of Yandrik Incorporated, a spin-off company of MIT Touch Lab in Cambridge. In 2005, Dr. Manivannan has set up the first Touch Lab in India at IIT Madras, which is also known as the Haptic Lab. He holds PhD and ME degrees from the Indian Institute of Science, Bangalore. I welcome Sir for the inaugural speech.
Thank you, Madam. Good morning to all. I'm very happy to hear about the VJEC and its noble visions from Father Joseph. I'm very happy to hear all the plans from our principal, Benny Joseph. And I'm very also happy to know that such an advanced topic is chosen for FDP. Virtual reality and augmented reality itself an advanced topic, but combination of virtual reality, augmented reality, and robotics is even more advanced topic. I'm very glad that VJEC is always willing to bring the most advanced topics to its faculty and students. I'm sure they will keep such a noble vision or ambitions in the coming days as well. So in the next few minutes, I'm going to talk to you about how robotics can be combined with virtual reality and augmented reality, and our work in the last 15 years in IIT Madras. We run a lab called Haptics Lab. Haptics is the science of touch. In this Google Meet or Team Meet, Microsoft Team Meet, we could only see the slides. We can only see the faces. We can only hear, but can we touch? Touch something that is 2,000 miles across. Can we imagine our hands to be 2,000 kilometers long? That is the power of haptics in the coming years. Right now, we don't have the technology. We are working on this technology to have 2,000 kilometers long hands in the few years, coming years. So in this haptics lab, which is combining with virtual reality and augmented reality, which is promising a lot of applications, haptics lab can make it much more powerful. In the simple virtual reality and augmented reality, you can just see things and hear things. You cannot touch things. When we touch the virtual objects, then the application becomes much more tangible, much more useful. That gives you the complete immersion. The goal of any virtual reality and augmented reality, by its definition, if you look at it, the complete sensory substitution. One spectrum of the virtual reality is completely virtual world, 100% virtual world. The other end of the spectrum is a completely real world. The combination of this virtual and the real world together, along with the sensory substitution, is what the goal of the virtual reality in general. So haptics also needs to be substituted. Otherwise, the immersion is not going to be complete. Inducing a specific behavior in a human, not necessarily human, it can be in an organism as well, using artificial sensory stimulation, while the organism has little or no awareness of interference. That is what the whole grail of this virtual reality, augmented reality in general. So with this aim, we set up this first haptics lab or touch lab at IIT Madras 15 years ago. Although this touch lab, haptics lab can have numerous applications in games, entertainment, what we decided to focus is medical training simulation in India, which was very much lacking. The patients were not, cared very well in India compared to other countries. They were now considered as guinea pigs for all kinds of experiments. We thought advanced technologies like this should be beneficial to the society in taking care of the patients. So one of our global contribution is that in all the Apple phones, if you have experienced it, there is a very good touch feedback called the Haptic Engine that is designed by our students. I'm very glad to that we have a global contribution from a very remote corner of the world, Touch Lab at IIT Madras. This virtual reality and augmented reality, it's a highly disciplinary. It is not just the computer science and engineering science. It includes the medical science as well. It includes the psychology as well. It's a most interdisciplinary field, I would say. We need to understand how our mind is actually perceiving, sensing. The whole virtual reality is about perception, how well your sensory is substituted. So the psychology has to be understood. In engineering, if you look at it, we are actually measuring things. Without measurement, there is no science, there is no engineering, right? Since we are working with the sensory substitution, we need to measure the how well sensory is substituted. So we need to measure that as well. So we call that particular field called the psychophysics. In IIT Madras, we run a semester course called psychophysics, in which we teach our students how this mental events can be measured and then used for designing advanced virtual reality and haptic systems. So the whole focus, I wanted to convey this to all of you, is that human focus, human perception. It is not the software, computer science, it is not the hardware as in engineering, it is the how well the human is perceiving. Can we engineer the entire system, hardware or software, to the human perception? The focus should be on the human perception. If you search any kinds of lectures in virtual reality and augmented reality, mostly they'll be focusing on only the hardware or software. But in India, we wanted to focus on how well human is perceiving. The whole design, the whole gadgets, it has to be designed very well for the human. In fact, I'm going to declare to you that the future of virtual reality is in India, not in advanced countries like US or any other countries. That is because there is nobody else in the world who can understand the human perception better than our Indians. But unfortunately, all this knowledge is packaged in religion, which needs to be brought to a rigorous science. Just to give you a glimpse of what a psychophysics is, because the entire talk is about a psychophysics, how well we can measure this sensory substitution, this mental events, right? So one hint is that if we have to measure the perception, then somehow if we can find out the relation between what is the input, that is a visual stimulation or the auditory stimulation, sound waves, or the haptic stimulations as force, somehow if we cannot find out the relation and equation, then that is a way to measure. This is then a whole crux of the psychophysics course that we teach in IIT Madras. So the entire haptics feeling or the virtual reality feeling of our human, it's all mimicked in the machines, in the robotics, in the virtual reality. Here in this slide, I'm trying to show you when you touch an object, what is actually happening. The contact forces from your hands is all sensed by a lot of receptors in your skin and the joints. It is conveyed to the brain, and the brain as the musculomotor systems, muscles to move the hands, and therefore you get to know the environment better. The similar thing is what mimicked in the machines. We call it as a machine haptics. And that is advanced robotics. I'm going to tell you this haptics devices we have designed is as advanced device. What is it? Advanced robotics. What is the difference between the robo and the haptic devices? I'm going to tell you later. There are several haptic devices already existing in the market. These are few haptic devices. So this robotic devices, you hold the end effector of the robot and then try to move. And when you move, you get a resistance. You can be programmed to give a resistance or a texture or the shape of the object. That's how you get a feeling of touching. But all these robotic devices, haptic devices, have a major problem that it is not suitable for virtual reality and haptics, because all these robotic devices have a very limited workspace. Any robotic device specification is one of the most important specifications, the workspace. This robotic devices has very small workspace. Whereas in virtual reality, we need a very large workspace, maybe infinite. So these haptic devices have to be changed to a redesigned specifically for virtual reality and augmented reality. And we have an idea about what are the different things we can do in a virtual reality. These are the different graphs we do it in the real world. Similar things we should be able to do it in the virtual world as well. So recently we have designed some of the haptic devices to get rid of this disadvantage of the workspaces, mount the whole device, robotic device or the haptic device onto the hand itself, so that when the hand moves, still it can apply forces on this. But the disadvantages of this mounting the robotics on the hand is that it is very heavy. It interferes your immersion. It is not natural. Then we are coming up with a very fingertip itself. Can we mount a small robotic device on the fingertip itself? So one of the things I wanted to remind you is that robotic device need not be like a human. Any robotic device which is trying to mimic the human motion is called the robotic device. Any machine which is mimicking the human motion is the robotic device. So even the small device which is attached to your finger can also be called as a robotic device. So when you touch a virtual object, this small robotic device on your fingertip can give you the feeling of the friction or texture. Again, the engineering challenge in this is that if it is generating forces, then the force has to be transmitted back to the ground. How do we transmit back to the ground? That's a lot of engineering challenge. Some of you coming from the engineering background, you would appreciate how much hard it is. There are several other robotic devices. We call it as a haptic devices, right? So that can be useful in a virtual reality to play several games. For example, the popular game, even though we don't want to encourage all the children playing the gun games, right? With a real haptics feedback, this is one good example. Or giving the motion in the virtual world, this is the motion platform. The whole platform actually moves depending upon where you are, giving a feeling of you are in a vehicle or a space shuttle, right? This is another example. Now, haptic device, we would call it as a haptic device, and somebody else would call it a robotic device. This is a main important point I wanted to highlight. What is the difference between robotics and haptic device? In a robotic device, if you hold the end effector, if you try to move it, you cannot move. because it is not back drivable. It is not designed for now moving the end effector, pushing the end effector from one position to another position. It is designed to be commanded the end effector to move from one place to another place, not the from external forces. Whereas haptic device, you're holding the end effector and then we are trying to move it. When you're moving it, you should not resist in a free space. It should be zero friction free, right? When you should be able to program it. Whenever there is a virtual object we are hitting, then you should resist as much as possible, right? This is the major difference between the robotic devices and the advanced robotic devices like haptic devices. This is why I call the haptic devices as advanced robotic devices. In the robotics, there will be backlash. Backlash means since it is using gears, even if it is there is some backlash, doesn't matter. But in a haptic device, a backlash cannot be tolerated at all. It has to be backlash free. Now, control system, if you look at in the robotics, they can use like a position control or a force control, whereas in the haptic devices, we are using the impedance control or admittance control. So with this small background on what are haptics and what are the challenges in virtual reality and haptic devices, I'm going to show you some of the works we have done in the last 15 years for our medical community in India. For our medical learning, experiential learning is very important. It is not just visual seeing and hearing. The doctors want to touch the device tissues. They want to palpate the tissues, push the tissue, and then find out whether there is any disease in it, right? So to help them, we have made maybe about 10 different systems in the last 15 years. All our devices, all over the demos are in our YouTube channel called Medical Haptics. You can actually look at the all the demos since I have very limited time over here. I would like to highlight only one or two demos. So the first demo is the epidural injection simulation. Those of you who are now gone through the labor pain, they would understand how difficult, how painful the labor is. In order to alleviate the labor pain, the doctors give an epidural injection, which is a very, very risky procedure. If the doctor does a small mistake, the pregnant lady will have a lifelong problem, neurological problem. To practice it right now, it is being practiced on the human patients, right? So we wanted to avoid it. We have developed this simulator where the doctors can practice this highly risky epidural injection procedure onto the in the virtual reality and the haptic environment, and then they can go to the patients. And this is a laparoscopic surgery. Laparoscopic surgery is everywhere now. Right? So again, all this surgery or practice on the human patients. If the doctor does a mistake, the patients have to bear the cost of the mistake. So we want to use these technologies to reduce the risk to the patients. This is a successful simulator which we had come up with. IVF training simulator, in vitro fertilization training simulator. Again, and any IVF doctor damages first 30 patients before they are competent with the procedure. So we wanted to reduce it. So the entire procedure is practiced in a virtual reality with a real haptics feedback. Again, I'm going to show you the demonstration. Probably let me show you here one simulation. Is it visible?
Yes, sir. It's visible.
Can you see the demonstration? You can see the haptic box that is giving the real feeling of IVF procedure. So the user puts on the head-mounted display and then holds the haptic device and then does the variety of procedures. The virtual environment gives the feeling as if they are in a surgical theater, and then they could see all the instrument output depending upon the kind of interventions they do. So the haptic device inside this box is giving the touch feedback, whereas in the virtual reality, visual feedback gives the ultrasound image, depending upon whether they are hitting the follicle or taking the oocyte from the follicles and then embryo transfer and all these procedures. I would request you to go through these videos in the YouTube channel. So I would also like to show you this another device. This is our laparoscopic device. You can see in the laparoscopic surgery, at the left side, there is two haptic devices for each hands. This is a highly 5 degree of freedom haptic device for each hand. So when the trainee practices the corresponding changes, they can see it in the screen, also in the head-mounted display. So there are several part tasks has been designed to hone the skills of the laparoscopic surgeons without the patients. Again, these videos are there in the YouTube. Please, whoever is interested, you can take a look at it. Coming back to the slides, I'm very glad to see that this IVF training simulator has been transferred. The technology has been transferred to a Singapore company, and the Singapore company is taking that technology to the global market for 100 crores. And this is another simulator, CPR training simulator. All the doctors or all the paramedics, they are supposed to know the CPR training. And now we have designed this CPR training in the virtual reality with the haptics feedback. This is the advanced cardiac life support training. All the doctors have to know, not the paramedics, all the doctors have to know this procedure, first aid procedure, as soon as a patient with a heart attack comes. The whole thing is now being practiced in virtual reality, so that the doctors are ready when the heart attack patients comes. And this is one training simulator we made for Indian Army some 10 years ago. This is a trauma care training simulator. When a soldier is lying down in the battlefield with a gunshot wounds, how the body soldiers should respond with all the first aid procedures is practiced in this mannequin. This is a completely mannequin. This also can be considered as a robotic device, which is mimicking all the human movements. So at the legs, the blood is oozing. The soldier have to apply a tourniquet and all these procedures, lift the arms and put the injection. All this they can practice on this mannequin. This is completely instrumented. We have transferred this technology to Indian Army, and the Indian Army is using it in many places now. And we are very glad to say that we have saved about 2,000 crores to the Indian Army now. And this is again another CPR module which we have designed it, and then our startup company is taking to the market now. So not only for skills training, all these technologies, advanced technologies can be useful. It can also be useful for rehabilitation of these several diseases. For a stroke rehabilitation, for example, how haptics and virtual reality can be useful. We have collaborated with the Sricita Trinal in Trivandrum, and we found that this advanced technology is much better than whatever they have right now with the traditional rehabilitation technologies. And this is the first haptic device we have designed, and this is the device we have used in the IVF training simulator, or all others are our medical simulator. And recently, we have started as Center of Excellence in VR and Haptics in IIT Madras. This is the first innovation center in India focusing on virtual reality and haptics. We call it as a Experiential Technology Innovation Center, XTIC. So in this center, we are aiming something very, very massive project. In the next 20 years, we want to make India as a virtual reality corridor. Just like an IT corridor, India is known throughout the world. We want to see that India is called as a virtual reality corridor in the next 20 years. That is our aim, that is a vision. And for this vision, we are working on several, just like any infrastructure development projects, putting the road first, right? For our virtual reality corridor, we are laying the road by teaching virtual reality courses to all the students, not only IIT Madras students. We are coming up with the virtual reality courses, online courses, and partnering with our industrial partners to take it to the entire India in a massive scale. And we have a consortium called Consortium for Augmented and Virtual Reality in order to achieve this massive vision. We call it as a CAVE. CAVE itself is a virtual reality system. You all may know that is a 6-walled projection systems, but we call this as a consortium. So in order to join this consortium, all of you can, who are interested can join. They have to just send a blank email to hapticslab@gmail.com, or they can visit the website called xtic.org. It also lists what are the different benefits of joining the consortium. So with that, I thank you, the organizers and the principals and the chairman for giving an opportunity to talk. I'm very glad to see VJEC with a noble vision, and I'll be happy to help on whatever way we can from IIT Madras. Thank you so much, and good luck for the rest of the talks. And I'm sure it is going to be exciting to everybody. Thank you.
Thank you so much, sir. Thank you so much for that beautiful words. Now I welcome Professor Danuj Mohan, Assistant Professor, EIE Department and Organizing Committee member of this FDP, for giving an overall idea about the program.
Good morning, all. Is it audible, ma'am?
Yes, sir, it's audible.
Okay. Good morning, all. Virtual and augmented reality are used to enhance the perception of the real world by integrating virtual objects to an image sequence acquired from various camera technologies. Numerous AR applications in robotics have been developed in recent years. I am privileged to inform you that our department is organizing an AICT Training and Learning Academy sponsored online faculty development program on virtual and augmented reality for robotics at Vimaljyothi Engineering College, Kannur, Kerala from 12th to 16th July 2021. The aim of this FDP is to provide an in-depth understanding behind virtual reality, augmented reality, virtual hardware, and software applications. It will equip the participants with the skills to apply these tools and techniques in healthcare, education, gaming, and engineering fields. It is also proposed to have an assembly of eminent persons in their area of specialization with fair share of invited and keynote talks in all relevant fields of augmented reality, virtual reality, and robotics for the benefit of the participants. In this FDP, 200 participants from all over India are participating. 18 experts from IITs, IISc, BARC, TCS and CEOs of the industries are sharing their knowledge on these Fridays. Dear participants, please note that attendance in all is mandatory. Attendance come feedback from link of every session in the Microsoft Teams chat box only. E-certificate shall be issued by AICT Training and Learning Academy to the participants obtaining 80% attendance in the online FDP and scoring above 60% in the exit test. Everyone, please mute your mic and video while attending the sessions. Only unmute the mic for doubt clarification. Test will be conducted after the final session of FDP. Everyone's cooperation is expected. Thank you all.
Thank you, sir. Now I welcome Dr. Christopher, Professor VJEC and co-coordinator of this FTP for delivering vote of thanks. Over to you, sir.
Thank you, ma'am. So it is good morning to all. I deem it a great honor and privilege to propose the vote of thanks on this memorable occasion. Let me first of all start by giving glory to the Almighty God for making today's occasion a resounding success. Now, I would like to propose hearty vote of thanks to our beloved chairman, Dr. Joseph Pamplani, for his benedictory address and inauguration of the ATAL sponsored 5-day FTP program on virtual and augmented reality for robotics. On behalf of E&A department and ATAL, I express our deep gratitude to you, Father. Next, I would like to thank our principal, Dr. Benny Joseph. He is a person speaks less and do many wonders. After having taken the reins of administration, the campus have achieved a new vigor and vitality. On behalf of E&A department and ATAL, I express our sincere thanks to you, sir. Next, I would like to thank the expert talk, Dr. M. Manivannan, Touch Lab Biomedical Engineering Group, Department of Applied Mechanics, IIT Madras, has given a valuable and motivated talk about the virtual and augmented reality with haptics. He has given that the robotics used in medical applications with VR and AR, and also he has combined the biomechanics, psychophysics, robotics, mechatronics, computer graphics, and neuropsychology, where the AR and VR is used, and also the human and machine haptic interaction, and the way the applications used in IVF simulator and laparoscopic devices, etc., in medical applications for the doctors. So with this excellency, he has delivered a talk which will be enthusiastic to the participant in this VR and AR application. On behalf of the E&A department and ATAL, I acknowledge our gratitude to you, sir. Next, I would thank our reference father, James Sellankodu, manager, VJEC Group of Institutions. He is the man behind us to organize this program. On behalf of the E&A department and ATAL, I acknowledge the sincere thanks to you, Father. Next, I would like to thank Reverend Father Lasser, Bursar of VJEC Group of Institutions. On behalf of our E&A department and ATAL, I sincerely thank you, Father. And Father Pius and Father Thomas and Father Subin. So all the administrative members of this institution, I thank you one and all. And our PRO, Sebastian sir, on behalf of E&A department and Atal, I thank you, sir. Next, I would like to thank our organizing committee members, Professor Dhanoj Mohan, Professor Shinu, Professor Reshma, Professor Shamia, and Professor Jinsa, and also the anchor, the Achala Prasad. On behalf of E&A department and Atal, I thank you all, one and all. And all the head of the departments of our institution, I thank each and every one on behalf of E&A department and Atal. Thank you one and all. And all the faculty members of our institution and other department staff members and the management representatives. So I thank each and every one on behalf of E&A department and Atal. So by this, I will conclude my vote of thanks. Thank you, one and all.
Thank you, sir. So with this, we'll come to the end of the inaugural session. You can stay logged in and we'll start the session soon. Over to you, Glenn, sir.
Especially special thanks to our guest, Dr. Manivannan, who has delivered an excellent talk, and the management representatives, our principal, and okay, now we are going to continue with the sessions. Okay, already the expert of next session is waiting, so I hope we will continue it and give the break after that. Dr. Anmol Srivastava is from UPES, is the expert who is going to deliver the talk of the first session. Sir, are you available there?
Yes, sir. I'm available.
Yes.
Good morning.
Okay. Good morning, sir. Good morning. So I call upon Jinsa Miss to introduce our guest. Okay, I think the network is not good. Now I will.
Sir, hello.
Just okay. Are you ready, or shall I make?
Sir, am I audible?
Yes. Yes. Sorry, Snega Jose. Okay. I welcome Snega Jose to introduce our guest. Please.
Okay, sir. Fine. Warm good morning to one and all.
Turn on your video also. No issue.
Sir, here. Okay, sir. A warm good morning to one and all. You can participate shooting 8 hours a day. Warm good morning to one and all. You can practice shooting 8 hours a day. But if your technique is wrong, then all you become is very good at shooting the wrong way. Get the fundamentals down and the level of everything you do will rise. We have right here Dr. Anmol Srivastava to embed our knowledge in fundamentals of virtual and augmented reality and haptics technology. At present, he is serving as an assistant professor at School of Design, UPES Dehradun, where he heads XR and LXD lab. Anmol completed his PhD under Professor Pradeep Bhumia in UAE and HCI lab in the Department of Design, IIT Guwahati. His doctoral research output has been conferred with various travel grants and prestigious awards nationally and internationally. In 2017, he was also selected as an ACM SIGCHI student ambassador from India at the 50th Turing Award ceremony, San Francisco, to represent SIGCHI community and the future of HCI research and practices. The Turing Awards were also referred as the Nobel Prize of Computer Science. He has several other valuable achievements too. His research interests are towards exploring the potential of emerging technologies to aid utility, usability, and creative self-expression in various contexts and use cases. I consider it a great honor to welcome Dr. Anmol Srivastava to light our knowledge on fundamentals of augmented and virtual reality and haptic technology. Welcome, sir.
Thank you, ma'am. Thank you for the introduction. And good morning, everyone. It's great to be here amongst you all. And hopefully, let's get this thing started on VR and AR by basically starting with what we are sort of trying to look into the fundamental part of it. And what I'll be going through is quickly, actually, I'll be running through most of the things because AR and VR are actually quite intense. But let's get started. So I've already been introduced, but let me also introduce where I am at present. So this is where I am. This is University of Petroleum and Energy Studies, and I'm serving in the School of Design. And as you can see, it's located in this picturesque location at the foothills of Himalayas. And we have recently set up a lab, what we call as XR and Interaction Design Studio. And we are sort of working on all sort of cool technologies and trying to get into every space possible, looking into virtual reality, projection mapping, tangible interactions, mixed realities, etc. And these are really the core areas with which we are currently focusing on for this thing. And at present, we are working on different areas in AR and VR, primarily dealing with education, health and well-being, fire safety training, cultural preservation, empathy and tourism. And I'll be also sharing some of our research work as well as the students' work which we are doing. So in today's session, we are primarily going to look into what exactly is AR and VR. We'll look into some of the fundamental concepts, what are there, and what sort of technologies are we looking into when we're talking about AR and VR. But before that, or before even going into AR and VR, if you really look into the current landscape, why is it that so many companies, big leaders like Google, Microsoft, Facebook, etc., right, and so many, you name them, are just jumping into this AR and VR? And why is it that you would also want to learn in this space? I mean, because there are so many areas, right? It's not just AR and VR. And if you really look into the way we live at present, we are sort of bombarded by information, right? Right from our mobile phones to our laptops to our smartwatches. We are continuously surrounded by information, right? And what this means is basically like when we were living in from this has been given by Matt Sunderstrom. When we were living in ancient times, we were quite close to the reality. We were only looking towards the future. There was this present and the past was just behind us. Sort of like, if you really say, like, in this part, right? And then the realities sort of started changing when we started moving towards a more civilized way. So this is a shopping cart where objects are right within our reach. We are now limited in a box type of a room, but nonetheless it is there. And then with the invention of or the proliferation of electronics and coming of GUIs and other things, right? Devices getting smaller and smaller and screens being embedded in everything, we sort of started moving towards an abstract way of living. Where you have all these graphical user interfaces, which are abstracted notation of a real world scenario, right? And what happens is with all these abstraction and everything happening, we were surrounded by a lot of information. And as the famous scientist Herbert Simon has said that a wealth of information creates poverty of attention. So what does this have to do with AR or VR? Because if you really look into how AR and VR is primarily, so these are the technologies which, what you can say is they focus your attention on a very specific thing. And at present, while the digital world is composed of complete a virtual reality or a fabricated environment, and this is the physical world where we live with artifacts and everything, we are sort of trying to move towards the convergence of physical and the digital world together, where we have all this augmented reality and different things coming up. But primarily, if you really look at the way in which AR and VR is, these are technologies that uh, engage our attentions and drive our focus to where it is exactly needed. But apart from that, there is also one more thing. It makes learning easy. It increases the engagement. It caters to different learning styles, and it sort of brings histories to life and is leading towards an experiential learning. Attention being one of the most important resources, hence AR and VR are being banged upon by these huge industries. And if you really look at the revenue models as to the share of how these technologies are going to be like in the near future, um, it is estimated that this whole industry is going to be around $150 billion industry, and this is just in its nascent stage. Estimate goes more than 300 billion also in near future. So before we dive deeply into AR or VR, let's just at least start with a basic definition of what we mean by these things. So virtual reality is something which replaces reality. It is a computer generated or a virtual environment where we are sort of cut up from our realities. It is a synthetic world. Whereas augmented reality is something where we merge the physical world and the virtual world or the digital world together. And it is a composite view. The only difference being that here the world which is remains quite real. So all in all, what you can say is if you turn on the opacity or turn off the opacity, we'll be in AR or a VR part. Some of the terms that you might often hear about these AR or VR things is with virtual reality, that is VR, AR, which sort of enhances the physical world, and then you have mixed reality, which is somewhat comprising of an augmented reality, as augmented virtuality, which is not exactly VR, but how we move in a virtual environment, which is replicated through a real motions and etc. Right? And then you have this term XR, which is often quite commonly heard, and this is a wide card sort of term for any sort of reality, augmented, virtual, or mixed reality. Right. So let's just jump into virtual reality and see what exactly we mean by it and what are the basic considerations we need to keep in mind when we're talking about virtual reality. So I hope I'm able to share this audio also, but I'll just like to play this video. Do let me know if you can hear the audio.
So audio is not connected actually.
Audio is not connected.
Yeah.
Okay.
Increase the volume. Increase the volume. That's enough.
Okay. I hope you guys can hear now. But nonetheless, even if you cannot hear the audio, it is still fine because
it's fine.
yeah. So this is year 1985, and somewhere in Paris, this thing was showcased to the audience in a cinema hall, and that was for the very first time that this sort of thing was seen by the audience. And it is often said that as soon as the people saw this train arriving towards them on this big white screen in front of them, they jumped from their seats and started running out. And this was because primarily none of them had seen such a thing before. And to them, this was a very immersive experience, and it felt like the train is really jumping onto them or coming near onto them, right? But we have come a long way from that. We now have these small compacted headsets uh, and advanced headsets, which sort of really takes us to a different reality. As has been said by Chris Milk, virtual reality is a machine, but inside of it, it feels like a real life. It feels like truth, right? So sort of, if you really look into what we mean when we are saying AR or when we are talking about virtual reality, so just like your earphones hijack your ears or your auditory senses, virtual reality sort of hijacks your visual or the visual senses as well as auditory senses, right? And altogether, when we are wearing a VR headset, we sort of get illusioned, or our brain gets tricked into believing that we are in someplace else. So how did we arrive over here? Because if you really look into from like late 1800s, there have been different attempts to sort of create virtual realities. And in this sense, virtual is really a very broad term, because it's not just in the present definition, but we're also talking about the way in which we would like to imagine how we can fabricate different realities. So with the kinetoscope coming, and I would say that the breakthrough actually happened in around 1962 with Morton Heil creating this a thing called Sensorama, which had this immersive way of audio as well as visual. It also had this olfactory as well as wind blowing on your face and other things. And in around 1967, Ivan Sutherland created a head-mounted display um, for virtual reality, or which is said to be the first VR headset or a mixed reality headset in that case. There were different attempts, primarily in military research as well as research done by NASA. And then there were cave displays. But what we really see is that there was a huge slump after late 90s. And for a long time, VR was not spoken of, and people really thought that this technology was dead. Until in 2013, all of a sudden we see Oculus coming in picture, and then Google Cardboard. And then we have so many of these headsets which are here right now, right? And each with each advancement, the level of immersion being increased and all these things. So what creates a compelling virtual reality experience, and how come that these devices, as they are improving, are also leading towards a better user experience while we are talking about VR? So as mentioned by Fred Brooks, for an effective virtual reality experience, the user has to be immersed in a virtual environment effectively. And it also implies that the user has a dynamic control over the things he or she is experiencing in a virtual environment, right? And what this really means is that um, the VR hardware should sort of emphasize upon good head tracking, or movement which should provide autonomy to the user, or the agency to the user. And this can be achieved by proper tracking techniques, the way the rotation of the head is, or the position of the body is, or by using body as an input. The VR experience should be natural. And what this means is that whenever a person is interacting in a virtual environment, he or she should be able to use the hands or the controllers or gestures or speech as a mechanism for input to interact with different objects or the environment. And at the same time, VR should also give a sense of presence, that the user is completely immersed in it. And when all these three things are combined, we say that the VR experience is actually a quite an effective one. So there are really different sort of displays in which VR can be utilized. One of them is typically what you are commonly familiar with, the head-mounted displays of different headsets. But then there are also different ways in which VR can be utilized, such as a display called Cave. This is a cave-based display where it is a room and the user goes inside it, and there are projections happening in all directions, all six or three directions. So the user can look in front in these three directions, and also down, top, and sometimes at the back also. And what happens is these displays are sort of calibrated by optical track sensors or cameras. These things are put on the goggles, and when the user is really moving the head, this display sort of change according to the user's perception. And what this really means is that you can be in a virtual reality environment if you are looking at a movie, right? Or if you are looking at a 2D screen. But that does not really give you the freedom to change the perspective, because if you are even looking at a screen, or let's say a 3D movie, as soon as you move your head, you are able to see the person who's sitting next to you, or you're able to see the room, right? So the view does not change according to your head movements. But with virtual reality, this is the main thing, that as soon as you move your head, the view should also change, or the perspective should also change according to your head movements. And with the cave display, this is possible. But then again, there are limitations because it can only track for one person and not many people. So this effective change in perspective is happening only for one person. Then there are different projection maps and the way people interact. Like, for example, this one is what we call as magic wand for cave, and this sort of thing is utilized. And what cave displays really stand for is cave automatic virtual environment, where projectors are directed between 3 and 6 of the walls of the room, and the user can look around, right? But at present, the most commonly utilized headsets, what you are typically aware of, are somewhat like Google Cardboard, and they support 3 degrees of freedom, where you can actually move around and look into different space. And the primary interaction with virtual environment is happening through gaze-based interactions, or the movement which happens is also through gaze-based. So what this really means is that you can only look around, but you cannot move forward with these headsets, right? So it only so you can sort of experience an environment by moving your head, but you cannot really move around in an environment. So the level of immersion is still lacking that sense, right? But then again, you have these advanced headsets coming up like HTC Vive Pro, which sort of utilizes different controllers as well as sensors such as base stations, which sort of track the body movement as well as the headset movement, and also track the way you are using these controllers. And they're also able to provide you the haptic feedback. Or further along, like you have headsets like Oculus Quest. And what really happens is with this HTC Vive and other things, what you really see are these wires which are attached to these computers with huge computing capabilities and graphical processing capabilities. And sort of what you can say is these are tethered headsets. And headsets such as Oculus Quest, these are untethered headsets which do not have any wires attached to it, and you can freely move around in a room. Both of them support movement, like HTC Vive also and Oculus Quest also. Vive has higher processing capabilities because it is attached to an external computer. So virtual environments which require high graphic rendering and all are supported by Vive. Whereas Oculus Quest is really a standalone device with somewhat less computing capabilities. But the plus point is that you are free to move without wires getting entangled to your body. And through each of these headsets, the interaction is based on controllers. And these controllers provide an effective way in which a user can interact with virtual objects, the way people can move in a virtual environment, and also pick up or manipulate different objects, move around as such. So with HTC Vive, you have this controller with a trackpad in between where you can sort of select different objects. You can move by teleporting to one place or from one place to another. It also provides you these haptic vibrations, just like you would do in a real world, because suppose I pick up a bottle in a real world, right, and I keep it on a table. So there is a small vibration which can be felt. And such type of things are also supported by the controllers in both of these devices. All in all, Oculus Quest also supports something called as hand tracking or a finger tracking. So along with this, like the controller-based interaction, what you can also do is you can interact with your hand as well as you can move around your fingers. And with the latest edition of Oculus Quest, like further ones, what we are also seeing is that they're also introducing hand presence, whereas you will not require a controller to interact with. So there are several key concepts that when we talk about virtual reality, we should keep in mind. And these concepts are really like 7 of these concepts, and primarily dealing with autonomy and agency of the user, presence and immersion, embodiment and FR, cognition and empathy, proprioception and motion sickness, haptics and pseudo haptics, and boundaries and redirected walking. So let's talk about the very first one, that is the autonomy and the agency part of it. So what it means is, when we are talking about autonomy, is that the user can actually choose their own perspective in the scene, and the user can control the virtual camera. And they can actually choose to navigate in a scene in many different ways. And in most VR environments, allow them to teleport or provide some kind of menu functionality. But if you are using a 6 degrees of freedom headset, you can actually also walk. The third example here is that the user can actually choose to interact with any object. And what this really means is that whenever we are trying to interact in a virtual environment, we are sort of looking into the physics and gravity part, is what something the user expects, that the object with whichever they are interacting with, they should interact, or that interaction should be more and more natural. So unless and until the objects with which the user has to interact are color coded or defined, the user tends to pick up or interact with any object in a virtual environment. And this becomes really important because when we're creating these 3D environments, we need to really look into exactly like what type of objects would we want the users to interact with, right? Another important concept is about the presence. And according to Miles Slater, presence is basically basically the whole goal of VR is to create a high degree of presence and make believe that the people are really in a virtual environment. Uh, so presence is basically a subjective experience of being in one place or in an environment, even when a person is physically situated in another. And this sort of thing really happens in a VR because you're really sitting in a chair, but when you wear the headset, you feel like you are in a different world or an environment altogether. Uh, so there is this International Society of Presence Research, and they define presence as a psychological state in which even though a part or all of individual's current experience is generated by human-made technology, part or all of the individual's perception fails to acknowledge the role of technology in the experience. So what this really means is that as soon as you wear this headset, you are sort of tricked into believing that you are located in a different environment altogether, and that the technology is not playing any role. But as such, most of these things depend on the type of technology we are using. Um, Another terms which are also associated with VR is what we call as the immersion part. And immersion is really the extent to which the technology delivers a vivid illusion of the reality to the senses of human participant, right? So altogether, what happens is basically it is the immersion which is producing a sensation of presence. So presence is a conscious state where we sort of feel that we are in a virtual environment, but it is actually depending on the level of immersion that is happening. And presence also becomes an important measure in some of the applications which decide how natural the interaction has to be in a virtual environment. So there are really different sort of presence or illusions which come into play because all in all, VR is sort of creating an illusion for the participant or the user who is wearing them. And these sort of are like what we call as the place illusion, or that is the feeling that we are in a different world altogether. Plausibility illusion is something that the feeling that the world is real and is responding to us. So what happens is that as soon as you wear the headset, you start feeling that are you really there? And when things start responding to you in a virtual environment, that you start feeling that yes, that I am there, right? So place and plausibility illusion play a big role while you are designing your environment in this case. And then that you have something called as embodiment illusion, which is the feeling that you have a body in a virtual world. And altogether, what happens is the greater the or higher the presence, the greater the engagement level or the excitement or satisfaction is there, and which also leads towards a higher reaction or action time in a virtual reality. And people behave as if they are behaving in a real world. And this can really be help people to sort of uh, overcome different challenges. Like this sort of thing is also utilized to mitigate fear of heights or maybe fear of spiders, etc., for different people. And higher presence also leads to a natural communication. Another important concept, which is very similar or is actually like for the embodiment illusion, is about the embodiment and the avatar part of it. That as soon as you are in a virtual reality environment, you sort of start feeling that yes, you belong to that environment. You choose a skin which you are comfortable with, and you can live within a VR environment altogether. So next, another important concept is about cognition and empathy, and what is motion sickness and haptics. So, for example, let's take this thing. This is an example of a virtual reality experience of how a person is driving a car. Right. So what you really see is that. So now this is a 360 video actually, but overall this is a VR experience where a person can actually start navigating inside a car. And as soon as they sit in this car, they are able to interact with different objects over here. And to interact with such an object, you need a setup like a set of keypads or a steering wheels, which you can rotate in real world and perhaps be virtually reflected onto a virtual environment as such. And what this really does is it sort of gives the user a feeling that they are located in a particular place. And it sort of starts building a mental model into users' mind that how a person in this scenario will act as such. And at the same time, they're also being familiar with a few practice. They will be familiar with how to utilize the haptics and the joysticks or the controllers which are there to drive this car. All in all, if suppose this was for driving, let's say, a rally race car, right? So a person who is playing this game, or perhaps in such an environment, they will deeply empathize with the driver or a rally driver, and would perhaps also be able to understand how difficult the scenario is for such a person. Right. Another important part which comes when we're talking about virtual reality is motion sickness. And motion sickness happens when the brain sort of receives a conflicting signal about the movement that the body is having in a virtual environment, and where the body is located as such, like in relation to this virtual environment. And what this really means is that suppose you are in a virtual environment and there is a conflict in the or sort of a mismatch which is happening in the senses and the what you're sensing on what you're seeing. You sort of start having this motion sickness, and this is really a subjective experience as to, because different people feel motion sickness in different ways, and it sort of depends on the type of headsets, the latency, or how quickly the scene changes, the type of controllers which are being used, the way people are sitting, or the eye movement which are happening. And to minimize such a thing, we sort of need better experiences which are more natural. And if any such thing happens, it's better to ask the user to basically sit down and perform or adjust different activities or adjust the brightness of the headset. So another part which really comes when we're talking about VR is, and this is recently with different sort of headsets which are coming into the picture or the scenario, is really basically about setting boundaries and creating safe measures. And this sort of thing has been created in Oculus Quest. So what you see over here is basically the home screen in an Oculus Quest environment. And the user can really sort of to create any experience. At this part. So over here, the user has the ability, or with this thing, that the user can define the boundaries as to where they can sort of experience the virtual environment. So seeing that a particular space is free, the user can move around and select the space as to like, let's go ahead and see which one. Yeah. So if you really see that the user is selecting a particular space where they're doing, and what this really means is that the user is selecting a boundary within which a virtual experience can be created, and also deciding how they can sort of move in this particular space with this what we calling as a redirected walk. And what happens is, as soon as the user steps into this space, they are sort of able to see the virtual environment, and as soon as they step out of the space, they start seeing these boundaries, and these really alert the user that they have to be cautious of not colliding into different objects which are around or into the environment. So this also acts as a safe measure for the user in this case. So with so many VR technologies and these key concepts that are to be implemented, what we really see is that for these VR technologies to be implemented, there are really sort of different enabling technologies. Some of them you might be quite familiar with. So there are 360 photos and videos, quite commonly seen on YouTube's now, where you can actually just move around and see all these panoramic shots which are stitched together in a 360 video or a 360 format. And it does not support any sort of movement, but only based on the 3 degrees of freedom. Then you have this stereoscopic display, which you have these two displays in a virtual or a VR headset, and similar in Google Cardboard and other things, where each of these displays are projecting different images in the eye. You have these cave displays, which we have already talked about, and then you have 3 degrees of or 6 degrees of freedom tracking. And with these tracking, what you can actually do is you can sort of move or look around in a virtual environment or move around freely. With 6 degrees of freedom tracking, it also gives you the ability to move in a virtual environment and is a much more natural way to interact. Uh, you have different type of tracking mechanisms, that is outside in versus inside out tracking. And what we really mean by these things is that if you really look at these headsets, like HTC Vive, right? So HTC Vive has these two base stations which are installed, and these base stations sort of senses the position of the head as well as controller. So this is the tracking happening from outside towards the or VR headset. But if you really look at Oculus Quest, so it has these different cameras installed at different locations, and the tracking of the environment is really happening uh, owing to these cameras. And this is inside out tracking which is happening. So this part is there. Another important part which is now catching up because more and more devices are sort of including this in is about the what we call as the hand tracking. Let me also share the screen and show you a video in this case of what exactly we mean by hand tracking. Let me share the screen. I hope you are able to see the screen. Right. So this is what is happening with Oculus Quest now. And what it supports is a complete feature as to you can track your hand as well as interact in a virtual environment. So you can interact using pinch and other manipulations. And this interaction feels quite natural. You need not have a controller with this thing. So ideally, if you do not have like Oculus Quest and devices, or you're using Google Cardboard or HTC Vive, you can also utilize devices like Leap Motion, something like this. This device, which sort of also supports hand tracking movement. And this was perhaps one of the very first devices which was there to use hand tracking mechanism. And it also provides natural way in which you can interact in a virtual environment, or as well as also in, or what you can say as in any sort of gesture-based interactions are possible with this thing. Spatial audios are an important part in VR now, and with what happens now is they're also acting as an indicator as to where the user has to move when they are interacting or when they are in a virtual environment, because these spatial audios provide cues to the user about the movement or about navigating in a virtual environment and a space. So altogether, if you really look at how these VR is like in which all domains VR is encroaching, so quite a lot many domains are being there, ranging from data visualization, health, education, training, entertainment, military, etc. Right? And what you really see over here is like this example, and these are series of examples basically, which showcase the use of virtual reality. The very first one being a storytelling example, whereas a person is actually has actually created comics in a virtual reality environment. And what this really gives them is the freedom to now, or gives the user is to freedom to experience comics in a very different way, far ahead from the pages, or just page. already discussed in the morning session. You might have like also spoken about VR in medical scenarios of how virtual reality is being used to uh, train surgeons and other people about various things of like in medical scenarios, or visualizing complex data which is there, and how basically it can improve the spatial ability of the people to understand the complexity in the data and how they can process it easily. It is also being used in industry to train people with different assembly or like different modules such as assembly or cleaning or performing different tasks. Quite innovative use which have occurred in social VR is in terms of like this example of meeting VR. With the pandemic and other things, since people were all locked down in a particular environment, right? So they could not meet face to face. So things or applications such as meeting VR really set a benchmark in understanding how social VR can be designed, because now people can simply put on the headset and their virtual avatars can be seen in a virtual environment. And what this really gives is like a flexibility to change the environment where the people are located. And sort of some studies have also highlighted that this sort of changing the virtual environment also leads to improvement in productivity as well as engagement amongst the users. Another interesting area of how VR is being used is to build empathy amongst the users. So for example, this is a VR experience which was presented in ISMAR conference, which highlights the use of VR for building empathy towards people with dementia. And over here, the person is actually located in a VR environment and sort of in a place where they can interact with this elderly woman and understand her difficulties as well. So this basically is a quick overview of what VR is. And primarily, if you really look into when we are talking about VR, few things also need to be understood in terms of understanding how the headset is or the headsets that we are using are. And mostly it all depends, like the presence is an important part in a virtual reality environment. And with these headsets, what we are really looking into is the resolution that, or the displays that each of these um, individual displays are there, which are being projected onto the eyes through this stereoscopic view, and the frame rate with which these graphics are displayed, or the rendering capabilities. Um, with the advances in the headset or the computing capabilities, we are seeing that more and more of these, like the resolution per eye is improving, the frame rate is also improving in these devices, as well as the latency is being reduced. And that is really contributing towards a fully immersive experience of VR environments. Next, when we talk about augmented reality. So augmented reality is something like in which you superimpose graphics onto a real world environment. And these can be any sort of sensory enhancements. It can be a 2D graphics or a 3D graphic. It can be audio or maybe geotags, any such thing. And so with this video, perhaps you can quickly have a look at it, what exactly we mean by. And this is by IKEA. So IKEA is this huge store which also provides people with their day-to-day requirements, needs. And they have sort of come up with this application where people can select different furnitures first on an augmented reality basis, and then decide which furniture they would actually like to buy. And all in all, with these AR experiences of how people can buy different furnitures and all, what they're sort of trying to target is that people should face less difficulties and be able to make choices more freely and independently as to understand. So this is like one sort of example. So by definition, what exactly happens is AR basically combines both the real as well as the virtual worlds, and it has a composite view. It's not just a visual object. It comprises of many different other objects. And AR is interactive in real time. And what this means is it has both explicit and implicit interactions. Explicit interactions are very similar to what you are having in a virtual reality environment, where you would sort of interact with the gestures or controllers or perhaps speech. But in AR, there is also something called as implicit interactions, which are primarily camera-based interactions, because when we are moving the, like primarily it is the camera which is overlaying these virtual objects. So when we are moving these cameras around, the interactions are happening also based on the camera. And primarily that most of these AR are registered in 3D. And what it means is that it aligns the virtual objects with the real world as if it is a part of the same world itself. Now, AR are also of a different type. There are marker-based versus markerless AR. With a marker-based AR, what we are having is you need to have a set of images or a different sort of markers which are recognized. And once they are recognized, a 3D object is superimposed onto them. A markerless AR is the example which you just saw about IKEA, how they're placing the furniture. And what these things are doing is they're sort of using different sort of algorithms such as SLAM, simultaneous localization algorithms and all, where you can actually view the environment, detect exactly where the position of the phone is or your AR device is, and then based on that, you are able to place the 3D objects. You also have different type of projection mapped AR. For example, in this case, you have the shoe, and this really is not a screen-based, but rather a project, something which is based on projection. And this sort of thing can be really utilized in a retail sort of an environment. So here, over here, what you see is a white shoe where the projector is actually putting on different designs onto this part. So you can actually select different designs of what type of shoe is there, or basically it can be for any object, right? And this sort of augmented reality does not require a mobile-based thing. So it is based on projection as well as depth sensors, where you're able to move this object and overlay or superimpose different environments. Another quite common thing is like head-mounted AR displays, and these are really things like what you might be hearing about Motion Leap or HoloLens, where you're sort of wearing the headset and you're also sort of seeing these things based on, and HoloLens is sort of based on this light field technology. So this is the example of, let me just see if I can select the audio. Can you hear the audio? Can you hear the audio?
No, sir. Just to play it. Yes.
Can you hear the audio now?
Yeah.
In this option.
No audio is there.
No audio. Right. So let's just continue without audio in this case. So what happens now is that with mobile-based augmented reality or AR-based things, right? So one of your hand is continuously occupied. And this really sort of creates hindrance in some of the tasks which people are doing. And here, what the use case, what you're seeing is basically about how a person can utilize a wearable device such as HoloLens, which are quite hands-free, and they simply wear it. And the user can be told about how a particular thing can be changed, or like in this case, how they can troubleshoot this particular equipment. And these sort of things can really be also utilized by these wearable devices. And what a person can actually do is they can utilize gestures to interact with it and also see things in real time. And this really eases their task in terms of the way automation is happening or industrial assembling part is happening, because people can get quite a lot of assistance with this sort of a technology. An important part to highlight here is that these HoloLens devices, they are also embedded with depth sensors, such as your kinetic sensors, right? Or miniaturized version of it. So it is also able to track the environment, track the hand location as well as the skeletal models, and then sort of help users interact in a VR environment. So there are several key concepts when we are talking about augmented reality, and primarily they depend on like things like augmentation and mediation. What we mean by augmentation is that we are superimposing. We are sort of superimposing information onto real environment, and these objects are spatially anchored into the real space, and they also sort of have spatial audios, right? And what we mean when we are saying spatially anchored is that the object is embedded in a particular place in an environment. But at the same time, there is also something called as mediation. So although we are sort of bringing these 3D objects into the real environment through augmented reality, things like Snapchat's filter or Instagram's filter, they are sort of acting as a medium for beautification or also acting as diminished reality. So as of now, what we are familiar with is that AR is sort of overlaying 3D objects, but with diminished reality, what we are also seeing is that there is a capability to also vanish actual objects that are there in a reality and see a space without a particular object. Then there is something called as a strong AR or a weak AR. And what this really means is that with a strong AR, you are sort of able to have 3D graphics which are superimposed, but the weak AR sort of just provides a basic information, sort of like your Google glasses which are there, which simply sort of gives a text-based information as such at most to the user or in a 2D graphical format. So a strong AR is something where you have these 3D models. It has a strong sense of position as well as where the user is located. But with weak AR, this sort of thing does not exist. And then you have a marker-based as well as a markerless AR system, where sort of you are, like we have already discussed, right? You present a marker and then object is superimposed onto different parts. So in this regard, I would also like to show some of the projects that have been carried out by us in the space, primarily in AR and VR space. So the very first project that we are doing currently is preserving Uttarakhand's traditional art form. And what we're really doing is we are going to different places in Uttarakhand and trying to encapsulate different cultural identities. Primarily, these are like what you can say in terms of intangible cultural heritage. So people like our students have actually gone to places like Almora, and then we come across this thing called as Apan. So Apan is this rangoli which we make in front of our doors during festive seasons. And this is a diminishing art form, and we sort of wanted to take this art form to the world and also preserve it and understand what are the deeper rooted meanings in this thing, because with the present scenario, people are really forgetting what these art forms are. So we really sort of created this environment in a virtual reality environment where we replicated Almora's environment. We created this 3D model of an Apan artist, and then sort of created a museum also where people can actually go and see different sort of what you can say artwork, or how this process is there for making this artwork in a virtual environment. And we further plan to basically take this work forward and embed more and more information as time progresses. And what the user can do is they can get sort of more sort of information when they are interacting with in this museum about different type of creepers or chockies that exist in this particular art form. The next work which we are sort of doing in here is in terms of understanding how virtual reality can be utilized to improve or to help people understand or get more aware about fire hazards and how they can sort of save themselves in this thing, because India stands fourth in this when we talk about fire accidents. And in recent few years, there have been severe accidents caused due to fire itself, which has taken many lives. incidents such as Surat fire or the Bhavana incident where 15 people were charred to death, or the Kolkata market fire. And there are so many things because of the laxity of people and the implementation of fire safety norms. So the moot question was, how can we utilize VR to drive general public about and make them aware about fire safety norms and also about the fire equipments? And primarily, if you really look at it, it's the firefighters who are working in these spaces, right? And even in India, if you really see, there is only one center in Goa which is there to train firefighters. So the problem is quite big in terms of which spans from general public to also a specialized group of firefighters. So the very first question being, how can fire training be provided to the masses? And how can it be utilized to also train fire safety engineers or firefighters, basically? So we started initially with a very small thing of creating smoke chambers and other things. Sort of like creating or replicating environments for e-learning modules or an IT module for fire safety engineers. And then sort of also simulating different type of fires which are there, where people can actually sort of get sensitized to what it is being caught in a fire. And this is just one of the simulations we have done of fire, of when a building catches fire. And this thing is still in progress, the simulation, what we're working on. And what we're trying to do is we are sort of trying to replicate fire behavior, we're trying to replicate smoke behavior, etc. In terms of AR and VR, we are also looking towards different applications where we can merge both of these technologies together, as well as provide a consolidated experience. So this is one of the applications which has been made by a student, and this is to make history more interesting. So students often feel that learning history or subjects such as social sciences are quite boring. So what can we do to sort of improve this experience for the students? And this is a complete application with a consolidated user interface, as well as how we can integrate augmented and virtual reality together in this case. So the person can really select different lessons in this one and sort of view them in AR or VR environment or a VR scenario. So if a person wants to look into a particular battle, so they can also play the VR environment, and this will sort of empathize them with the historical situation. Or if they simply point towards a particular part of a textbook, they can sort of see the relevant video as such in AR. And what this does is basically that we simply can upscale the existing models of the book, etc., to a VR environment. Or if we can utilize augmented reality to help improve tourism of a particular place. And what you are really seeing over here is mixing of storytelling as well as food tourism together. And this is a hypothetical app, a Zomato AR, where we are sort of trying to improve India's food tourism sector by facilitating different travel experiences. So when we often go to these old shacks in different places in a city, right? So each of them have a very specific history attached to it, oftentimes which is like many new travelers are unaware of. So can AR be utilized to help people or let people know about these different food joints and what is the history behind all of them as such? Or one another interesting use case which sort of came up was in health and fitness, that how can AR be utilized for different sort of if we want to train people, because when the lockdown happened, people were really sort of relying only on YouTube videos and they were not able to go to gym, etc. And with videos, the problem is that you only get a one-directional view as such. You are not able to understand different postures or move around and have a look at it. But what if you are also your workout trainer is an augmented reality-based trainer who is sort of able to help you decide the posture and which muscle group is being activated when you're performing a particular exercise as such. And this is just a proof of concept that we have made using a dummy mannequin, but it has to be further improved, or it is to be further improved. And what we are also planning to bring is to utilize this with a mixed reality headset, such as a HoloLens, which can really help people sort of exercise and get to understand it in a better way. Another use case which was done by me as a part of the PhD work was to understand how augmented reality can be utilized for improving the learning of the students, or improving the learning experiences rather. And the problem statement really derived because if you really look at, or if you have worked in an electronics engineering lab, you often tend to interact with equipment such as these CROs and other things, right? And especially these analog CROs, which are quite difficult to operate. And not many students or even um, people who are like interacting with it daily are aware of the functionalities. And at the same time, if you are rigging up a circuit on breadboards or any such thing, it really becomes a mess. And debugging such circuit really is a hassle, which sort of increases the cognitive load. And studies have really pointed that students really become frustrated, or nearly 78% of the students get frustrated in labs. And beyond a certain point of frustration, people simply get bored and they give up on learning. So we came up with this application of what we call as Ariel, which could be utilized uh, for rigging up circuits, getting contextualized information, as well as information as to how to operate different test equipment. And this is one of the demos for that. And this application had different features in it. Sort of like you could have a 3D view of the circuit when you point towards it, and it would also sort of provide a much deeper way in which people can assemble the circuit, because not many people are familiar with how to, or their spatial abilities are lacking. So they're not able to sort of understand when they look at a 2D circuit or circuit diagram as to how they want to assemble it. Or utilizing augmented reality as a guide to operate different test equipments which are there in the lab by providing different information to it. And what we are really considering while designing these AR application is how a personal workspace is, and how a particular VR experience is to be crafted so that a person can get complete view, or like a limited view in which the information can be provided. So for example, the circuit part, or like assembling the circuit, a person can double click on the objects or the 3D objects, and they can sort of get a proper understanding as to how a particular circuit is, or what is inside those circuit or a chip. Basically, they can interact and look into different ways. Getting information about different electronic components as such. Okay. So this was one part of it, where we would sort of utilize both marker and markerless tracking techniques. And what you really see is that we created this marker which fits on a breadboard. This was a marker-based thing. And for you, in terms of detecting the objects and basically like objects which are there in the lab test equipment, there was a markerless technique which was utilized. So although I would say this is marker and markerless technique, but altogether the detection really becomes the same at the end of the day. So all in all, there is definitely a marker which remains. Although the anchoring of objects or a virtual object becomes different case altogether. Or if we are also, or if we can sort of perhaps improve this scenario and we can combine augmented reality with an IoT scenario. And what if there is a database of all the errors that students are making while they're rigging up the circuits, and recommendations are made on an intelligent basis. So for example, in this scenario, the breadboard is able to highlight to students via AR where they are making a mistake. But it is not just like that there is a mistake. The interface you see over here is an interactive voice response, which also asks the students to basically answer a particular question if a mistake is repeated for an n number of times. And what happens is, like, let's say a student is making a basic mistake again and again. So this device would sort of say that maybe you should go and read this particular chapter and then come back and assemble the circuit or perform this experiment. So these were some of the work that we had done in terms of AR and VR, and understanding how it can be utilized in different contexts. So I'm open for questions. So if you have anything, you can please feel free to ask.
This is Vivek Kumar. Hello, sir.
Yes, yes.
Sir, good morning, sir.
Good morning.
What is the open source tools used in this project, sir?
Yeah, so what we are doing is, just give me a moment. There's about to be this cooker whistle blowing. There'll be a disturbance in a minute. Yeah, so what we are doing is, I utilize Unity over here. Unity is really this game engine which is used for making any of these AR or VR applications. You will need different tool sets for making 3D models, such as you can use Trimble SketchUp, or you can use any other 3D software. Vuforia is a plugin which is utilized for creating AR applications, but now ARKit or AR Foundations has been introduced by Unity, so you can also go ahead with that. But Vuforia is really easy because it is a direct plug and play mechanism for creating an AR application. Additionally, you can also utilize softwares like AR.js. You can also utilize softwares like AR.js or 3.js to create 3D models and then import it in JavaScript, if you are familiar with JavaScript. So that can really help. I hope I have been able to answer, address your question.
All are open source, sir?
I will not say open source, but it is free to use. Unity is free to use.
Can we design commercial products, sir?
Can you design?
Commercial products?
For designing commercial products, you will require license for Unity.
Sir, if you want to do research, means in which direction we can proceed, sir? All are mostly application tools. Any algorithm development or what we can, in which research direction we can take, sir?
So it really depends. I mean, so I belong from a design environment and a human-computer interaction. So I primarily look into applications of technologies, right? But if you are a computer graphics sort of a person who is working in image processing or computer graphics, you can also really look into areas like diminished reality or localization algorithms as such, right? But if you are working in application areas such as me, so I start looking into various areas where people can actually utilize AR and it can be beneficial for them.
Okay, sir.
Right.
Sir, I have a question.
Yes, yes.
Yeah, sir, I'm a school teacher actually. I'm not from any college. So I'm taking ATAL tinkering classes, ATAL tinkering lab for my students.
Yes.
So, sir, I just want to know, do we have something for these beginners from the class 8 to class 12 students? Some easy thing which they can do and they can explore augmentation?
Yes, yes, definitely. So there are different platforms. I will suggest two platforms, like Adobe Aero is there, and then there is something called as Minsar, MINSAR for Android. Adobe Aero primarily works on iPads, but you can develop augmented reality applications using that. And it's a very simple platform. All you can do is simply drag and drop 3D models, and you can augment any real spaces. You can use both marker as well as markerless techniques. So let's say that you have this book, right? And you want to pop up some 3D objects if a student points a mobile phone on a book, right? So you can also...
On Minsar also, sir?
Pardon?
Minsar also? Minsar
Yes,
is the same thing?
Minsar also works on the same way. So you can install it directly on your mobile phone via Play Store, and it will work in that way.
Okay, okay, sir. Thank you, sir.
Sure.
Thank you so much.
Good morning, sir. I have one question. Can I ask?
Yes, ma'am, definitely.
Sir, you have shown as far as that lab manual is concerned through augmented reality.
Yes.
So, how fast the teachers can develop this sort of manual and can give the 3D effect? Because nowadays everything is going on through virtual mode. So, if someone has to implement it, so what technology they should use, and what sort of prerequisite they should know as far as the teachers I'm saying in order to develop such manual, lab manual.
Yes, ma'am. Yeah. So actually, if you see, I mean, this is a big concern with AR or VR, that is content creation part of it. Because if you really look at it, there is a steep learning curve if you are not familiar with softwares like Unity, Unreal as such. So you will need to give some time to it. But like I mentioned, with these new softwares which are coming up like Adobe Aero or Minsar, you can sort of create applications over like with them. But there is still a limitation. I mean, you will these applications will not be so seamless compared to what you make in Unity as such, right? So altogether, teachers do need an authoring tool for making such an application. So that is still, I mean, I would say that this is an area which is still problematic for teachers also, although they want to utilize it a big time. But maybe you can experiment with Aero as such, Adobe Aero.
Okay, so Unity, that means they should learn first the Unity in order to develop that lab manual properly.
Yes, yes. So in my case, I made it on Unity by utilizing superimposing videos as such. There might have some tool which have recently come in. Although I did see some things, but I'm not able to recollect the names right now. Maybe perhaps I can just email it to them later on. Like, to search.
Yeah, please. That will be great.
Yeah.
Thank you.
Right. So do we have another question?
Any questions, please ask.
Will be taking for us to study this virtual reality software?
Pardon, I could not hear you. Can you please repeat?
How many days shall a person will take
Okay.
to take?
So it really depends. I think first on the enthusiasm level, but also partly on like what is the coding experience.
XOBA, capital letter SOBA. 1967. Hello.
Yes, please.
Yes, sir.
Yeah.
How many days
it will really, it depends like what is the coding experience you have. So if you have a certain coding experience, you can perhaps grasp it easily. But then again, if you're using platforms like Vuforia for augmented reality, most of the things are drag and drop in most of them. So altogether, I would say that there is a learning curve which takes around 4 to 8 weeks to get some grasp of AR or VR.
Sir, I have a question.
Hello, sir.
Yeah.
Hello, I have a question, sir. If I want to go for weak AR, what apparatus should I procure for my lab?
So for weak AR, basically things like what you can say Google Glass, right? Those sort of thing is there. But nowadays, like if you have any other mobile phone, also a low-end mobile phone, you can utilize that. So those will be weak AR in this case. But what really you are seeing is like with new capabilities which are coming, like iPhone now has a LiDAR capability, right? So more advanced features are coming in. So I do think that the weak AR definition will also keep on changing with as technology is changing, right?
So how do we develop that means screens, that transparent screens which we see in weak AR?
So those are like simply projected on Google Glasses, but what you can do is you can also utilize PNG or you can utilize PNG images also. So the same type of screens can also be created using mobile AR also.
Thank you so much, sir, for
using
your
2D,
kind reply.
yeah, using 2D graphics with a transparent background.
And your lecture was very interactive. It was very interesting to go through in.
Thank you so
Thank you,
much.
sir. Thank you for such a great lecture.
Thank you.
Sir, one request, sir.
Yes.
Can you list the softwares and hardware required, sir? As another sir also told in the PPT, sir, it will be helpful, sir.
Definitely. So what I'll do is I'll send an email to sir. I'll share an email with sir, and that will be circulated with you all.
Okay, sir. Sir, another doubt, sir, whether
Yes.
it is there in the Google Cloud, sir, because all the participants may not have that required configuration. We require big graphics processing now, sir.
Yeah. So with the AR and VR, there are several things that we have to keep in mind. I think I should have also covered that part. So exactly deciding what type of devices we want and where exactly, like, or what sort of AR or VR experiences that we are aiming for, right? So suppose you are going to a field with where you do not have sort of what you can say internet connection or internet connectivity. So in that case, you will perhaps want to maybe utilize applications such as which are preloaded onto your mobile phone itself, right? But in certain cases where you have good internet connectivity, you would perhaps not want to take up a space on your mobile phone and directly utilize the cloud. So what happens is augmentation can take place either through a cloud-based application where you simply look at a marker, it connects to the internet, and whatever the particular 3D object has to be augmented, that simply comes, and that data is coming from the internet, not being stored on your phone itself, right? There are different applications if you really talk about it. So if I talk about augmented reality as such, right? So you have different marker-based augmented reality techniques. You can use AR.js, you can use AR Toolkit, you can use Vuforia. If you are looking for body-based augmented reality, right? And what this means is that your complete body is sort of being utilized as a for augmentation. You can look into Lens Studio, and you can look into Spark AR Studio by Instagram as well as Snapchat. There are other tools also. I believe Reality Composer, Aero, and other things which I have already mentioned. These sort of things. And if you're really into the development part, like hardcore software development part with AR applications, you can look into AR Foundations, AR Core or AR Toolkit, or Mixed Reality Toolkit for Microsoft HoloLens. If you want to talk about virtual reality, so with virtual reality, you can sort of create 360-degree tours using Tour Creator or Sketch 360. You can use softwares like SketchUp or Netscape for creating 3D models. If you already have a VR headset, like Oculus Rift, or if you have HTC Vive, you can use software such as Tilt Brush, which are already there in virtual reality. Tilt Brush or Quill or Sketch or Gravity Sketch to create content in 3D itself in a virtual reality environment. There are other things like Steam VR is there, A-Frame, Sumerian, Oculus, so many other platforms which exist.
What are the different motion tracking algorithms that are going to be utilized in the VR?
Pardon, can you repeat the question?
What are the different motion tracking algorithms that are going to be used inside of a VR to provide the immersiveness or inside of a VR domain? For the
so motion tracking hardware for AR or VR?
not tracking algorithm.
I'm sorry. Can you please repeat the question? I'm unable to understand it.
Which are going to be to identify presence of the user inside of VR environment.
Sir, can you type the question?
Okay.
I think the audio is cracking in between, so I'm not able to hear. If you can just type it out.
So, you can type the question in the chat box.
Yeah.
Sir, Anmol sir,
yes.
Somebody want to start their research in AR and VR. Okay, like from where they can start it. It's a generalized thing. Our topic is the AR VR for robotics. Okay, so yeah, so some sensor part or whether it can be used for some implementation, some control algorithms like a position control or something in the robotics applications. How we can or where we have to start our research from for in this area.
So AR, VR, I mean, there can be n number of ways in which you are utilizing this AR or VR, right? So like primarily when we talk about robotics and all, right? So there's this thing called maybe object detection, or what you can maybe like path planning and other things can be done using this thing, augmented reality also, or also for providing sensor information as such, which can be directly overlaid on a robotic area itself. But exactly like it will really depend on the problem statement that you are looking into, because I mean robotics is still quite broad. So let's say that you are talking about assembly line, right? Or even in that, or automated manufacturing lines if you're talking about. So you can utilize AR over there itself for like one of the use cases which we already saw, for providing information or troubleshooting things. Or it can be simply to get access or to understand where the problem is occurring. Those sort of things can be done.
Sir, how we can validate the system? Just that is a system design we are going for this. Once this AR/VR based system we have developed means, what are the parameters for the validations? We can do some any modeling techniques. We can whether it is able to develop using this AR/VR technology.
Right. So, I mean, see, there are really two perspectives to this part, right? Even when you're looking for the research area and for the validation part of it. So let's say that you want to sort of control your robot through a virtual reality or maybe through an AR, right? So you might be perhaps looking into the accuracy and the precision part of it, of how well a robot can be manipulated or can perform a particular task in that sense, right? So that really comes in your algorithmic part of it. If you're engaging users who are particularly interacting with this machine and with this AR/VR system or an interface, then the parameters really will be in terms of the usability and the cognitive load of the user who is using it. So where exactly are we, like, which domain is our research lying in? Is it mainly in the engineering space, or is it really in a user-centered space? That has to be first looked into, because with the engineering space, things will be more technical in nature, um, in terms of the robustness of a system, the algorithms part of it, all those things, etc., right? Whereas with the user-centered part, things will be a bit different, because now the users and the human factors come into the play.
Thank you, sir.
One particular area where people have been using AR or VR is I had come across this interesting use case where tele-robotics were being utilized, using virtual reality, we were using tele-robotics, right? So a person would sort of interact in a virtual reality scenario, and the robot would be located somewhere else across the globe, and they can perhaps work on that. And these are really interesting use cases for things or areas of which are hazardous in nature. So there also robotics can play a big part, which can be combined with VR.
Yes, sir, it's nice. Yeah, Jyotis Korean, raise hand. Please ask your question. Yes. Mr. Jyotis, any question is there?
Sir, I want to ask one question. When you show us that displays us regarding electronics component in that platform, if we want to design such a kind of what you have designed, same way we have to design this and show to students. For that, which components or which scratch coding or basic knowledge we required for that?
Yeah, I worked on C# and Unity for making these things, and I took help of one of the students who made 3D models for me, right? Primarily it is Unity which was utilized along with Vuforia platform.
Okay, sir.
So I will also like to mention that, although AR and VR is quite big in that space, but it requires multiple level of skill sets. It will require you to be a 3D modeler, an animator. It will require you to have some sort of coding skills as well as user interface design skills, right? So most of the if you are limited, what you can do is you can perhaps approach a person who is in game development, right? Because what you are really seeing is, right, this Unreal Engine or Unity as such. These are all game engines primarily. And with AR and VR, you need to understand is that game engines are going to be the operating systems of the future. Okay, we will not be working on Windows or Macs as such when we are talking about AR or VR. It is these game engines that are driving these technologies. So having any understanding about Unreal Engine, Unity, Steam VR as such, these will be quite helpful as skill sets, or AR.js or A-Framer. These things will be really helpful. Right. So any other questions?
Dr. Anmol, can you type in your email ID in chat box so that we can contact you if required?
Definitely. Yes, I would love to do that, but I'm actually not able to access my chat. It's only available for team members.
Sir, please type it in WhatsApp also. WhatsApp group.
Yes, some issues there. We will fix it in the afternoon session, and I will share the contact detail of Anmol sir. Okay, I will share the contact detail, and once I get the PPT, I will share with you. Okay.
Yes.
Any technical questions now you ask? Other things, I will make the contact. Some issues there. I will fix it in the afternoon. Okay. Chat. Some issues there. I think so. So you can unmute your mic and interact with him now.
My name is Anand James. Can I ask a question?
Yes, please.
Yeah, thank you, Dr. Srivastava. That was a nice presentation. Thank you so much. When it comes to the an implementation plan, most of the time the challenges are in terms of compatibility of softwares, platforms, engines. So and again the knowledge base also. So do you suggest a process flow, something which can be followed from start to end?
Yes. So see, again in this case, right, I will again ask, like, what is that thing that you are going into? See, if it is primarily engineering oriented solution, that is like if you are dealing with the accuracy of how you are superimposing 3D graphics, or if it has to do with computer graphics, or localization algorithms as such, or image processing part, that is something which I will not be able to tell. But if you're really looking into applications part of it, right? You want to create or you want to utilize AR and VR in a particular use case, and you want to investigate how you can sort of really approach or arrive at that solution, or find out where you can use AR or VR. So what we typically do in design is we use this technique called user-centered design, where we go and we observe the scenarios where we want to bring in the application or a particular technology. We also look into, or we speak with different people. We take their interviews as such. And based on whatever findings we get from these interviews, from our observations, we sort of start brainstorming upon different ideas, and then come up with different scenarios as to how an AR or VR technology can be used. And then again with AR and VR, another big part is that we first need to see what type of AR or VR we are going to use. Is it a simple Google Cardboard experience, or is it a tethered experience with HTC Vive? Or can it be a mobile-based experience, or any such thing, right? So we choose upon all those things, we brainstorm ideas, and then we particularly arrive at a particular solution as such. So this was for identifying user needs, the thing which I just told you. But when you're talking about developing a particular AR application, right? So we need to create a workflow. First, we need to understand what all assets are required, what type of data will be required for our AR and VR application. So for example, let me highlight it with the use case. So I was working on this with this company, and they wanted to help with data visualization, and they wanted to get this data visualization for stock market, right? And what we were dealing with is really a real-time data from the stock market. So capabilities in which we can actually see real-time data, how we can import it in Unity, how we can create 3D assets, or we can manipulate 3D assets based on this incoming data from the stock market, how that can be done, right? So there are different platforms and plugins that are there, and we will just need to identify them. So once a workflow is created, I think then it becomes sort of easy to understand in which direction we can go ahead with AR and VR development.
Thank you, Dr. Srivastava.
Any more questions? Otherwise, we can wind up. Please come forward. And I am having your attendance, so attendance is not an issue. We can download the attendance directly from the Microsoft team, and it is automatically, it will be recorded there. And feedback, I will circulate it in the afternoon session. Once this chat issue will be fixed, I will circulate it. So any questions? Otherwise, we can wind up. Okay, thank you, Anmol sir, for your valuable speech and good presentation. And definitely it will be good for our participants. They gathered much more information from your informative lecture. And please share your presentation while it is in the final stage. Thanks a lot. And please keep in touch with us, and I will share your, with your permission, I will share your details to the participants. Thank you, sir. Thank you.
Okay. Thank you, sir.
Okay. My dear participants, please come back at 1 o'clock. Okay, so I'm leaving this break for the lunch interval and the session break. So after lunch, we will meet back at 1 o'clock, and afternoon there are two sessions. Both are very important sessions. One is introduction to robotics. Another one session is for your stress management session. Okay, known who is going to give an stress management session. So don't miss any other sessions. Please utilize at most this workshop to you as well as your students. So once again, I thank all of you for participating, and you use the same link for throughout the workshop up to 16. Okay. Any feedback if you want to tell, please unmute and tell me regarding the workshop side. Okay. Otherwise, we can end the meeting and again come back at 1 o'clock. 1 o'clock shortly we have to start the session, and so try to join from 12:50 onwards. Thank you all. You can log in the same ID. Okay, same link. Using the same link, you can log in again. Hello, sir. Yeah. Sir, tell me, sir. Yeah. Ma'am, tell me. Yeah. Attendance link I will send you, ma'am. Actually, we are having the